Do, 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 do. Hi, welcome to Math Wizards. Well, Math Wizards proudly sponsored by the greatest drink in the world, peach tea. Well, let's move on. Now, we've got a problem today and it's really hard to solve, so I want to share it with you peers. Well, what is the problem? The problem is the closest power line to the parking lot runs along a straight line containing points 0, 4, and 12, 10. At what point should the lightning contractors connect to the power line? And how much cable will we need? Well, let's look at the diagram first, shall we? Power line is here, runs along the black line, and the cable is right here. And you can look at this, it creates a 90-degree angle, and we'll tell you why later on. And the light is at point 619. Remember, the dotted line is the cable. Well, the solution is pretty simple. The light is at 619. The shorter distance from it is a perpendicular line. Remember, a perpendicular line, because it will make the shortest distance. And that is a very important fact. Well, number 2, find the equation of the line that contain these two lines. Well, we have to find the two equations of these two lines. The slope of the power line is 10 minus 4 over 12 minus 0, which equals to 6 over 12, which also equals to 1/2. Correct, Jason? Correct.
Yes.
Equation is, therefore, y equals 1/2 x plus 4. You know why? Because 4 is at the y. Thank you, Jason. Therefore, we know that 4 is the y-intercept because it's on it. Number 3, since the perpendicular line have slopes that are negative reciprocals, that's an important fact. Another important fact. When you have a perpendicular line to that means you have a slope that is a negative reciprocal. Therefore, the slope of the other line is negative 2. 1 over 2 equals to negative 2 over 1 if it's a negative reciprocal. Let's move on, shall we? Thank you, Jason. Right, the equation of this line is therefore y equals negative 2x plus b, right? Well,
Right.
not really, because we're missing the y-intercept. Find b by subbing 6 and 19. Therefore, 19 equals negative 12 plus b. And therefore, b, you move the negative 12 over, b equals 31. Therefore, the point of the line, the equation of the line equals to y equals negative 2x plus 31. Well, that's step 4. Now we'll move on to step 5, shall we? Okay, good idea. Alright, step 5. To find the point where the line meets the power line, it is 1/2 x plus 4 equals negative 2x plus 31. Because there are two lines, there are the two lines in the diagram. Well, therefore you do the solving, all the jiggle, x would equals to 10.8. And sub the x value to find the y value. Right, Jason?
Yes.
Yes. Y equals 1/2 times 10.8 plus 4. Y therefore equals to 9.4. Wow. Hence, the contractor should connect into the power line at point 10.8 and 9.4. Yes. So, it will be around here. 10.8 and 9.4. Fantastic. Alright, but that's not it, right? Because there's a second part to it. Well, to find the length of the cable required, we have to use step 6. Use the distance formula. And that is length equals square root of x2 minus x1 squared plus y2 minus y1 squared, which equals to, put the numbers in, 10.8 minus 6 and 9.4 minus 19, which equals blah, 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 blah. We do all the work, which equals to 10.7. Therefore, the contractors would need about 10.7 meters of cable to connect the light and the power line. Well, that's it for today. Thank you all for watching. Good night, and a Merry Christmas. How do you stop this?